Hello everyone, welcome to our next class on derivative of logarithmic function due to public demand. In here we shall look at how we differentiate a logarithmic function, that is if you are given a function a to power bx, then from there we shall look at if you are given natural log, y is equals to natural log of bx. The other one we shall look at if you are given log base a of bx, how do we differentiate all those? And at the end of this class, you'll be able to differentiate all kind of logarithmic function and be able to do more and more complex or complicated equations on the same. So here, welcome to this channel. It's called Professor Wilson Kamami, where we simplify mathematics together for the sake of you students so that you can continue enjoying your degree or your diploma wherever you are, so that you can be able to achieve future goals with mathematics. So continue sharing with your fellow students and recommend to them this YouTube channel. At the same time, continue recommending the topic that you like us to tackle on our comment section. So let's look at this one. If you are given now y is a to power bx, what will happen if you differentiate y with respect to x? The function will remain the way it is. Then you add natural log of this base, natural log of a times derivative of the base. What do I mean? If you are given, example 1, if you are given y is 3 to power x, I know majority of you bear witness, we can introduce logarithm on this one and use what we call implicit differentiation. We tackled implicit differentiation in one of our videos. It's called implicit differentiation. So in this case, we have y is equals to 3 to power x. We don't want to introduce logarithm because we can differentiate this one the way it is. So change in y over change in x will be 3 to power x. It will remain the way it is. But now natural log of 3, we said you must introduce natural log of 3 times the derivative of x. When you differentiate x, you get 1. So we have 1 times 3 to power x, natural log of 3. And that's the answer. If you are given example 2, y is equals to 3 to power 2x, you have to differentiate that one. Change in y over change in x. The equation will remain the way it is, 3 to power 2x. Then natural log of 3, the natural log of this base, times the derivative of 2x. And when you differentiate 2x, you get 2. So the answer will be 2 times 3 to power 2x natural log of 3. For those who know the law of logarithm, this can be 3 to power 2x natural log of 3 to power 2, which will be natural log of 9 if you want to simplify further. So that's how we differentiate this kind of function. If you are given a constant to power function of x, so it remains the way it is, then natural log of this constant, then to power derivative, then we multiply with the derivative of that power. It is key we notice that one, because majority of the students have been sending me questions on how we differentiate 3 to power x, 2 to power 4x, and before I show you how we introduce logarithm, you can be able to differentiate this one directly. You know that it will remain the way it is, then natural log of our constant, then you differentiate the power, our function. As you can see here, this is where we have the function of x. You differentiate it and you get that one. Even though you are given 3 to power x squared, example 3, y is equals to 3 to power x squared. So it is the same, or 3 to power 2x minus 1. It is the same, dy over dx. The function will remain the way it is. Then natural log of 3, our constant is 3 here. The natural log of 3, then you differentiate 2x minus 1. And here you get 2. So you get 2, 3 to power 2x minus 1, natural log of 3. So there is nothing new on this one. That's how we differentiate this kind of function. Let me show you how we derive to this one. Maybe I can show you here the same example 1 on how we derive to this one. having shown you how we differentiate 3 to power x as our example 1, we have done example 2 and example 3. If you are to use the first principle rule, you find that the function of x, in this case we have 3 to power x. What is function of x plus h? It is 3 to power x plus h. So now the first derivative of x will be limit as h approaches a. And in this case we have f of x plus h minus f of x all over h. In this case it can be h as it approaches 0. So we have limit as h approaches 0. What is my function of x? It is 3x plus h minus 3 by x all over h. And you realize that based on the law of indices, this is the same as limit as h approaches 0. This is the same as 3 to power x times 3 to power h minus 3 to power x all over h. Here I have split this one based on the law of indices. It is 3 to power x times 3 to power h. So we can factor out 3 to power x. We can factor out 3 to power x. We will have 3 to power h minus 1 all over h. And since this one is a constant, we'll have 3 to power x limit as h approaches a or 0 of 3 to power h minus 1 all over h. And you realize this one, you get a natural log of 3, or what we call the natural log of that constant 3. That one, you tackle that one when you be handling limits. So we'll have 3 to power x natural log of 3. So that one will be covered on limits, and on limits, when it comes to limit, you can be able to see that we tackled 5 classes on limits and more classes on limits to come later in the day. So let's look at how we differentiate natural exponential. In this case now, that was A. Now B, if you are given y is natural log of bx. So when you are to get change in y over change in x, our main focus is on this bx. So it will be 1 over bx, then times derivative of that bx. So you get b over bx, you get 1 over x. So this is our now main focus on this one, our second one, because we said you look at logarithmic function in 3 parts. So how do we differentiate logarithm? Example, if you are given y is natural log of 2x, how do we differentiate this one? Maybe you can start with the x, natural log of x. So the change in y over change in x will be 1 over x. Remember, our main focus is this x. So it will be 1 over x times derivative of that x. And when you differentiate 1x, you get 1. So you get 1 over x times 1, which you get 1 over x. And that's why you find most of the book, they will tell you, if you differentiate natural log of x, you get 1 over an x. But as a mathematics student, now you need to know how we get that one. Example 2. If you are given y is natural log of 2x, okay, you need to get change in y over change in x. We said our main focus is that 2x. That's our main focus, 2x. So it will be 1 over 2x times derivative of that 2x. And when you get the derivative of that one, you get 2. So you get 1 over 2x times 2, which you get again is 1 over x. So that's how we differentiate natural logarithm. 1 over our natural, that value of natural logarithm times the derivative of that one. Maybe we can take example 3. Y is equals to natural log of x squared. How do we differentiate that one? dy over dx. We said our main focus, it is this x squared. So it will be 1 over x squared times derivative of x squared. So you find it is 1 over x squared. So derivative of x squared, it is 2x. So that now the answer will be 2 over x. Because now this x and this x will cancel out. You'll be left with 1x at the denominator. So it will be 2 over x. That's how we differentiate natural logarithm. Even though you are given more examples of natural logarithm, maybe we can take more, those are 3 examples. We can take 2 examples of natural logarithm, then so that we can be able to proceed to the other part C of logarithmic function. Example 4. Example 4, if you are given y is natural log of x cubed plus 1, it doesn't matter. How do we differentiate this one? Change in y over change in x will be 1 because our main focus is x cubed minus plus 1. So it will be 1 over x cubed plus 1. We said it is 1 over that function times now the derivative of that function, which is x cubed plus 1. When you differentiate x cubed plus 1, so you get it is 1 over x cubed plus 1. So when you differentiate this one, you get 3x squared. So, and the answer will be 3x squared all over x cubed plus 1. That's how we differentiate natural logarithm. Natural logarithm of x cubed plus 1, it is 1 over that one times the derivative of the same function inside our natural logarithm there. And when you differentiate x cubed plus 1, you get it is 3x squared, and that will be the answer. So maybe even though you are given example 5, on y is equals to natural log of sine x, it doesn't matter. Our main focus is sine x. So dy over dx, this is natural logarithm Ln. So our main focus is this sine x, so it will be 1 over sine x multiply with the derivative of that one, the derivative of sine x. So you need to get the derivative of sine x, which based on our classes on trigonometry, we know it is cos x. So you have cos x all over sine x. So dy over dx will be cos x over sine x, which majority of you know that when you have cos over sine, it is the reciprocal of tan, because tan is sine over cos. So cos over sine is 1 over tan, which is cot x. So regardless of the kind of question you'll be given, when you see natural logarithm of a function, it is 1 over that function times the derivative of that function. That one is very clearly shown by this formula. If you are given natural log of bx, it is 1 over bx, then you differentiate that bx. So that is our example of natural logarithm. Let's look at the part C of logarithmic function. The third part of our logarithmic function is where you are given log base a of bx. You know, I'm just using bx to represent any function that you can be given there, but we know you can be given log base a of that bx. So what happens to this one is just almost the same with the natural logarithm, because our main focus is this bx. So it will be 1 over bx times, this time we are adding natural logarithm of our base. And in this case, natural logarithm of our base a. So it is natural logarithm of base a, then times the derivative of our function, the way we are doing with the natural exponential. Example 1. Maybe you are given y is equals to log base 5 of 3x. How do we differentiate that one? Change in y over change in x will be 1. Our main focus is 3x. It is 1 over 3x. But we said in this case, we have base 5, natural logarithm of 5. Then you differentiate your 3x. And when you differentiate your 3x, you get 3. So it will be 3 all over 3x natural log of 5. So you get it is 1 over x natural log of 5. And that's the answer, because the 3 and the numerator, where you have 3 and denominator, you have 3 to cancel out. So that's how we get the logarithmic of a function, base something. Example 2. If you are given y is equals to log base 2 of maybe x cubed minus 4, how do we differentiate that one? It's simple. dy over dx, because it's a function of x, we said our main focus is this function. Log base 2 of what? X cubed minus 4. We said it will be 1 over x cubed minus 4. Then you add natural logarithm of base 2, natural logarithm of 2, then times the derivative of x cubed minus 4. When you differentiate that one, I think you get 3x squared. So you have 3x squared all over x cubed minus 4 natural log of 2. And that's how we get the logarithm, how we differentiate. At least I have shown 3 parts. How we differentiate maybe 3 to power 2x. How we differentiate natural logarithm of bx. In case you are given constant before, we know constant, you treat it as constant. So you only focus on natural log of that one. So I have said I have given examples on the same. And the third one, I have said if you are given log base something of a function, I have said it will be 1 over that function, natural log of that base times the derivative of that function. And we have taken 2 examples on the same. Maybe a clear illustration on how we get this one. I said this one, we said if you are given a constant to power function of x, we said you may introduce the logarithm. That's why you see me, I'm teaching this one at the logarithmic function. Because if you are given that one, we can be able to introduce a logarithm. Maybe I can illustrate this one again with the example that we did, the first example, on how we can be able to introduce logarithm. And maybe I can give you more and more questions so that you can practice on logarithmic function. Let's look at how we can handle that one. So I'm going back to the first case where you are given y is equals to 3 to power x. And based on our first case, we said change in y over change in x will be 3 to power x. It remains the way it is. Then natural log of this constant, 3. Then you differentiate power, which is x. That's why we said you get 3 to power x, natural log of 3, because here you get 1. I think I gave the formula as the first case in this video. But in this equation, again, this one, you can introduce logarithm. Let me introduce natural logarithm. So I'll introduce natural logarithm on both sides, natural logarithm of 3 to power x. What happens with this one? Based on the rule of indices, natural log of y will be equals to x natural log of 3. And in this case now, we can do what we call implicit differentiation. When you talk of implicit differentiation, we agreed we have a video on implicit differentiation. We have a class where we looked at implicit differentiation. We said if you are given function, you can differentiate with respect to y to x in both sides. So when you differentiate natural log of y, we have seen in case 2 when you are given natural log of y, it will be 1 over y. When you differentiate natural log of y, it will be 1 over y. But based on the implicit differentiation, you need to add change in y over change in x is equals to, when you differentiate x, you get natural log of 3. Because here you have to use product rule. You hold x constant, differentiate natural log of 3. But natural log of 3 is just a constant. So it is like you have 3x. When you differentiate 3x, you get 3. So when you are differentiating x natural log of 3, you get natural log of 3. So now, the other thing we said in implicit differentiation, you make change in y over change in x the subject. So you multiply with y, you have y natural log of x. Natural log of 3, sorry. And what was my y? Based on implicit differentiation, my y was 3 to power x. So it will be 3 to power x natural log of 3. I think this one with this one, you can be able to see where the formula was coming up from. So it is at the implicit differentiation. I know if you have not tackled the implicit differentiation, it might look a bit complicated because we said when you are differentiating y, we have y, we must add change in y over change in x. Make sure you revisit that video on implicit differentiation so that if you find this kind of equation and you are forgetting how we differentiate that one, you can use what we call introduced natural logarithm. Then by implicit differentiation, you'll be able to get the same answer. Maybe that's why I wanted to make that clarification. More examples on the same. I would like the more example equations. Let me say equations so that you practice. And maybe if you have some problem, we said you can reach me out with one of the way, either it's on WhatsApp or through email, and I'll be able to respond on that one immediately. So that's all about logarithmic function for today. So thanks for watching. As we agreed, continue sharing with engineering students, those students who are taking calculus as a subject or as a unit in the year course, so that we can be able to continue. Even the statistics, because more videos on statistics will be coming, so that we can be able to simplify mathematics together. Thanks for watching.